Hi, I'm Rob, and we're going to look at Ebean ORM's history feature, which is based on SQL 2011, or the temporal features of SQL 2011. So the main questions that this feature is looking to answer is what did this data look like in the past? So when you say data, we could say row or we could say object graph. And the second one there is providing an audit record of who changed what and when. So SQL 2011 has some temporal features in it, and the two that we're really looking at are those select as of queries and select versions between queries. So the as of gives us the ability to do a query as of, say, last week or an hour ago, sometime in the past. And effectively, we're looking to answer the question, what did this, say, row or object graph look like last week? And then the second query there, the versions between, that gives us sort of a who changed what when. So we're looking at a particular record, like for example, customer 42, and what changes happened to customer 42 over time. So some databases have these features built in. So Oracle DB2 SQL Server 2016. But we can also support these types of features in other databases, and for Ebean that's Postgres and MySql, and H2 of course. And we do that via using triggers and history tables. And that's not really a new thing. That's been people have been doing that for many years. So it's kind of tried and true approach really. Here's some links. I'm not going to go through those, but there's a documentation link and some the example code, which is where I'm running this code from. So the first thing we'll do is have a look at Oracle. So Oracle has native support for SQL 2011 with as of and versions between queries. So we're just going to jump in and run a query now. So flick over. So here I've got my Ebean query, which is doing a customer find as of a certain time in the past. So this was sometime earlier today or yesterday. And we're going to find where name equals Jim and find that unique object. And then we're going to invoke some lazy loading here. So we're going to effectively get two queries. And just to invoke the lazy loading, that the thing that Ebean's doing here is it's taking the as of timestamp, if you like, and applying it to the origin query plus any future lazy loading queries. So if we run that, we have a look what happened. So this was against Oracle. And here we've got our first SQL select statement followed by a second SQL select statement. So this is the lazy loading query against the address. Now if we have a look, well, I guess we can have a look here and say we found Jim, as comments was, but not as we know it. So if we have a look at the end of that query, so we have the from clause here, from customer, as of timestamp. So this is the specific syntax for SQL 2011. And then with a bind value of the actual timestamp, where name equals another bind value. So our bind was as of timestamp and then Jim. Now the other thing here, we've got this timestamp here is the same as this timestamp here. So this is our second lazy loading query. So if we scroll across here, we've got from address as of timestamp where ID equals. So that's the query there. So let's have a closer look at that query. And let's jump over to look at it in Oracle. Okay, we'll chuck it in here. So we're doing our select, as of timestamp where name equals. So if we just move this over, check it in here, we're going to need one of those. That, run that query. So we found our row, Jim, but not as we know it. And obviously, if we can change this timestamp, so we can move forward and back in time. So if we run that again, we get a different version of Jim. So this was it's life Jim. And if we change that timestamp again, move way forward, we get Jim with the comment Klingons on the starboard bow. There we go. So what's happening here is that we're able to just view this the record of Jim back in time just using this as of timestamp query. So I think that's pretty straightforward. What I'm going to do now is show you a slightly more interesting query. So we're going to do an eager fetch. So this is actually going to do an eager fetch. In this case, we can join. So we get a slightly different SQL statement. So run that. Let's have a look. Just the single select statement this time. Excuse me. And well, let's check down here below. So, well, we've got two table aliases here. So we've got this is the address and this is the customer. So we've got from customer as of our timestamp. So we had that before, and now we've got a left join in here to address as of timestamp. And then this is the on clause for that. And we've got as of timestamp and Jim. So the what's happened here, or what specifically Ebean does, is that it goes, we're doing an as of query, and I'm going to join to address, and then it detects if address has history on it or not. So if I quickly show you that, because I actually haven't shown you that. So if I go to customer, customer has at history. So that's telling Ebean this the base table, if you like, for this entity has history. And if I do our join to billing address, where are we here? Billing address, we go to billing address, that's also got history. So when Ebean is doing this join, it's going, oh, address also has history, therefore I will also have the as of timestamp clause, if you like, in the join. And so this timestamp and this timestamp are the same. And that's pretty much it. I think I've got a version of that query actually up above here somewhere. Here we go. So if we run that, we see Jim, but not as we know it. And over here we've got the street address, which is U2 Street, Tree City. And if we change that timestamp, move the timestamp forward a couple of seconds, then we've got Jim, it's life Jim. And if we go across here, we'll see a different address, Museway, Blackstar. Okay, so basically, I've said that a few many times, but we can build an object graph as of a certain timestamp. So we can do the root query with timestamp plus joins plus lazy loading, all using the as of query. And Ebean will choose to incorporate the as of clause based on whether the entity bean has got at history on it. So that's the as of. So let's just go back there. Native as of with Oracle, and it's pretty straightforward there. So I guess I'll jump down here and say what I also showed you there was the propagation of the as of timestamp for the secondary queries and the lazy loading. So let's have a look at the versions between, just down here. So this is a different query here. I've got two timestamps, start and an end, and we're doing a query. This is Jim's ID value. We're saying find the versions of Jim between these different start times. So actually, I'll just run it in debug for the moment. So what that is doing, actually, so for version, we're getting a list of version of customer. So what's version? Version is a wrapper which has a bean, a start timestamp, an end timestamp, and a diff, which is a map of properties that have been changed. Value pair is a new value and an old value. So we're getting a diff of properties with new values, old values, start and end date, and the bean itself. So actually, if we look at that, we've got three versions. The last version there is Jim comments Klingons on the starboard bow. Nothing there. And for our diff, we've got, if we click on the diff there, so the new version of the comment is Klingons on the starboard bow. The old version of the comment was it's life Jim. The new version of the version property is 9. The old version of the old value was 8, and when updated is also changed. So what this query is doing is saying, I'm looking at Jim, I'm seeing what the changes that have occurred to that customer between two start timestamp and an end timestamp. So we rock that on, and we'll just look at the system out. So we've got Bean, same ID, it's Jim. We've got the different comments, Klingons, it's life Jim, but not as we know it. And here's the diff. The last one's empty, the prior diff. So this version is it's life Jim, and the previous version of the comment was but not as we know it. Okay, so let's have a quick look at the SQL. There we go. Just check it up here. Right. Right, so with this query, we're putting in a start time and an end time. So these are two special columns, if you like, that Oracle provides. And here we've got from customer versions between timestamp. And we've got our two timestamps, start and end. And then we ID equals, which is 21. Okay. Now I think I've got a pre-prepared version of this dude. Here we go. Right. So we got Klingons on the starboard bow, it's life Jim, but not as we know it. So this is column 5, which is the comments. So it's all fairly straightforward, really. I will go back here and just say that's what we're doing. Start date, end date, find the versions of Jim between those two dates as a list of this version wrapper bean, if you like, which has the bean, a diff, a start timestamp, and an end timestamp. And you would use this in your application if you're building some sort of audit of, you know, what's changed in this record between two dates. Now, let's go back to the slide there. I think what I'm going to do now is jump in and show you how this works in Postgres. So with Postgres, we want to do the same two queries. We want to do the as of and the versions between, but we don't have that built in to Postgres in the same syntax, so we have to use a slightly different syntax. And we'll do that using history tables. So what Ebean provides is that it will generate the DDL for us. So it'll generate the DDL for the triggers, the history tables, and we'll also see it creates a view. And while that's good, the other important thing that Ebean will do is that it generates the database migration changes. So the thing is, once we have this history table, then we have changes. So if somebody wants to add a column to the customer table, well, we do that. We also need to rebuild the trigger, add the column to the history table, and update the view as well. So that's what Ebean does with its DB migrations. And this isn't particularly new. People have been doing this for a while. So yep, let's get into it. So we could just run the queries again as Postgres, but I'm not going to do that. I'm just going to jump in here. Got these queries already rerun. So let's have a look here. We'll go up at the DDL first. So when we add at history onto an entity bean, as part of the DDL generation, Ebean generates this as extra DDL for Postgres. So firstly, it will alter the table customer, adding the sys period column, which is a timestamp time zone range. So that means it's got a lower and an upper bound of timestamp time zone. And it defaults to start of current timestamp. This next update is optional. It's basically if we've got existing rows in customer, we can update the sys period to start with a when created. So Ebean will detect if there's a when created column and add this update. Thirdly, here we're creating a table customer history, which is this is sort of Postgres specific, saying like customer. So that's going to create a table, the same structure, but no primary key and no foreign keys. And that's general for history tables. They won't have primary keys and foreign keys. And it won't also add indexes. So you can selectively add the indexes that you want on the history. So you probably just want them on ID and the period. It's this period. And then what we're doing with Ebean is we're also going to create this view, customer with history, which is select star from customer, union all, select star from customer history. So this we're doing this so that it makes life easy in terms of how we generate our SQL. And that's kind of good when you want to do your own SQL and not use Ebean, for example, to do the queries. Next part here is we've got this trigger or function, and this is going to trigger for update. It will insert into the history table, and if we scroll across here, we see all the relevant old values. And similarly, if we do if there's an update, delete, then it will similarly insert into the customer history. And there's an adjustment here. New sys period is the current timestamp. And this is registering that function with as a trigger on the table. So before update or delete on customer, for each row, execute the procedure. So now once we have this in here, the point is that it doesn't actually matter what or who updates the database. The triggers will maintain the history and hence the audit log. So you don't have to use Ebean to do insert, update, deletes. You can use any tool you want to update the database. So now let's have a look at the Postgres version of the as of query. So before we had, with Oracle, we had from customer, and then had some special syntax in here. And this time, what Ebean does is goes, we're doing an as of query against customer, which has at history, and therefore our from clause is not from customer, but from customer with history. So we're going to select from the view, and then we add this additional predicate in here, which is that the sys period is contained within, the as of value is contained within the sys period range. It's a better way of reading it. And name equals Jim. So that's that query. This second query down here is where we did the join. So I've put in the literal values here. So normally you'd see question marks, of course, so the bind values, but I've put the literals in here. And what we've got here is this is the eager fetch, where we're doing a select as of against customer, but we know customer's got history, so we're putting in the customer with history table view. And then we're going to join against the billing address. And now the billing address also has history, so we also put in the address with history view as our join table for address. And we have our on clause just as per normal. But actually what we're doing is we're adding this predicate effectively to our on clause of our join. So we're saying join to the address with history view, where normal clause plus the period is contained within our as of timestamp. And then this range is for our base table. And we can't put that up in the from clause because that's not supported with Postgres yet. So we're adding it as a first predicate on the where clause. So let's run that. So if we run that, this is Postgres, got slightly different data. Got Jim, power to the people, red square. And if we adjust it this time, we're getting Jim, the power and the passion, blue sky. Okay. So probably the thing to say here is that when you're looking at the SQL, the range checks are early. They're either on the join or the first part of the where clause, and then after that, these are the application predicates. So you won't have 9 greater than 8, but you'll have some other much better application predicates, I'm sure. And that's kind of it. So let's go back to the presentation. So with Postgres and MySQL and H2, we need to do a bit more. So we provide the as of inversions between queries by using effectively the view and additional predicates that we add into either the join clause or the first clause of the where first predicate of the where clause. Ebean can generate the DDL and also the DDL for migration changes. And this is probably a major one because otherwise that's a bit of a pain. And this is not really a new thing. So there's plenty of presentations and links out there on similar content about triggers and such. So what Ebean does, we have at history, and then we provide 2 extra queries. There's the as of query where we give it a timestamp so we can see the graph, as of last week, and the find versions between query. Ebean propagates the as of timestamp for lazy loading, this point here, generally speaking, our application is using a database connection pool to talk to the database. So in terms of the user who, or for auditing purposes, we really want who created and who modified to be part of the database columns and provided by the application. So because we're using the same database user, i.e. connection pool. So generally speaking, you'll have those as well. Who created, who modified. And these history queries, yes, Ebean makes it easy for you, but they're pretty easy to do yourself. So you can do your own SQL, etc. I'm actually going to show you one other thing here, just to solidify it. If we jump into Postgres and look here at the tables, we've got customer table, which is, oh, okay, everyone close their eyes so they don't see. Okay, Jim, Power and the Passion. So this is the customer table, and it's got the absolute latest version of Jim. And in customer history, we see the, if you like, the old versions. This was Jim before. It was Power to the People and then Flower Power. If we looked at the view, we're looking at customer with history, we see the union all of both. And scroll across here, and we've got our sys period with our ranges. So just wanted to show you that in case that helps reinforce what's going on. Okay, so there's just a couple of fun slides to do. Upsides. So the upsides here with SQL 2011 in terms of history is that's all part of the database. It's not part of the application. So it doesn't matter if you're using Ebean or anything really to insert or update, delete your database. The changes will be captured. They're transactional and they can't be bypassed. So we can't miss out on logs or audit entries because you weren't using Ebean. Any client, the entries will be there, and bulk statements as well. So any bulk update statements, etc., bulk delete statements, those will also be captured in the auditing. In terms of performance, I would say that it's good performance because effectively we're on the server side, so it's either built-in or it's trigger based. So what that means is that we've not got the extra network traffic going between the database and the application server, for example. We don't need to fetch the old values in order to actually maintain the audit log, and because the old values are supplied in the trigger automatically. So that means we can do two things that we really like to do with Ebean, which is partial updates. Only fetch what we need, and then we're more efficient with the database. We can do the partial update. And the last one here is, hey, let's not even fetch from the database, just execute an update, stateless updates. And all of that is going to be in your audit logs, so that's good. Downsides. Well, the history is going into our old TP database. So when the history tables get big, if they're going to get big, then that's going to be a problem in terms of, well, we need to start thinking about archiving them and etc. We are putting extra load on the DBAs. Then they're not free, so we're having extra overhead for our old TP database. So it's not too bad though, in the sense that it's server side, its triggers are built in, so we're not talking about a lot of extra fetch or network costs. It's basically pure server side cost. If you're using Oracle and using Oracle Total Recall, well, they go a little bit further and they're doing this in the background with batch processing. So they've got some optimizations going on there, which are quite nice. And probably the big downside is the DDL side of things. So with Postgres and MySQL and things like that. So here we can do the initial triggers and stuff like that, and that's all good. But then we have to maintain them as we change our database design. So we add columns, we need to update the triggers, add the column to the history table, etc. The nice thing is that Ebean does that for us with DB migrations, but it is, otherwise a pain. So the last thing I wanted to do is do a quick comparison to changelog. So Ebean also has @changelog, which is quite a different thing, really. What that is doing is it's an Ebean insert update delete plugin, effectively. So it's capturing insert update deletes that Ebean's doing. And typically these are sent as a log in JSON form, and you could probably ingest them into Elasticsearch. It's probably the way to go. What this means is that, if you're not doing insert update delete through Ebean, you're not going to get them. They don't capture bulk updates, so we're just going to go, updating 100 or 1,000 rows, etc., in a single statement. Well, we can, but they won't be in the captured as audit log. And then the change logs also, this is probably the big advantage, they don't have to go into the OLTP database. They don't have to go into any database. They could just go as logs, as files. So at history or change log, now I think people will be using both. So for people who want sort of the gold standard in audit logging, at history is going to give that with SQL 2011. So it's built in with some databases. It's transactional. It's not part of the application code, so you don't have to worry about application developers getting it wrong or there being security holes and etc. like that. It's much tighter controlled, not bypassed by bulk statements, etc. Sure, it adds some overhead and weight to the OLTP database. So that's the downside. Changelog, well, sometimes we might not need all the guarantees that history provides. So in that sense, changelog comes into the play. And conversely, we might have to use changelog if we just have too much auditing requirement. There might be people who fall into that category. Well, there might be tables that fall into that category or particular transactions that fall into that category. So that's it. That's the end. Happy auditing. Cheers.